We're standing in the middle of a really busy park. We can see 320 beautiful mirrors instead of cantilevering from the building.
And if we look down at the ground surrounding us right now, we can see pools of light, and it's almost a quite dappled effect.
The people who are sitting in the park at the moment might not realise it, but they don't have to move to chase the sunspot. There's 160 patches of light on the ground plane here that are being delivered by the system. And as long as the sun's out, that sunspot will be in the same space all day, which is not a natural thing. Normally people have to move to avoid the shadows as they chase them and to stay in the warm patch, but you can sit in one of these patches of light all day.
Seems like the birds like it too.
Pigeons are having a good time in it.
Chippendale Green is a large patch of green space in an otherwise high-density neighbourhood on the outskirts of Sydney CBD. The green is framed by a stunning array of modern high-rise and heritage low-rise buildings. Looking toward the city is a striking structure with 2 glass columns that protrude from opposite sides of a 5-storey retail atrium. The building is One Central Park, a highly recognisable landmark signalling the entrance to Sydney's inner west suburbs, a short walk from Sydney's Central Station. The structure is peppered with a range of sustainable features, among them low-carbon electricity provided by a central tri-generation plant, real-time energy monitoring, and hydroponic green walls covering 50% of the building's surface area. Its numerous sustainability features are significant enough to have earned a 5-star Green Star rating, which culminated in One Central Park being awarded World's Best Building in 2014. The complex represents a bold and somewhat heroic move towards large-scale sustainability in urban design, the first of its kind in Australia. Hovering between the 2 towers directly over the lower retail precinct is a mesmerising but seemingly innocuous flat square surface, cantilevered 70 metres up in the air, housing a series of glittering mirrors by day and an expansive light show by night. Though its purpose may seem mysterious to most who pass by, this cantilevered structure is One Central Park's crowning jewel. Its mirrors are used to reflect the light captured and redirected by the heliostats below, providing light to areas that would otherwise be overshadowed by the surrounding buildings. It is thanks to the heliostat that sections of Chippendale Green are covered in light all day, providing a warm, open space for residents and workers to relax year-round, also ensuring natural light is significantly supplemented into the retail spaces below.
We're directly under the cantilever, so in the retail space we've got 5 stories of retail atrium that's naturally lit throughout the day. Running over the glass roof is water. There's about 30 to 50 mils of water that is just constantly running from one side to the other. And the rippling water softens the sunlight even further, so by the time it gets to the ground plane you've got that very dappled effect that the architect was after. And this is really the space where you experience the feeling like you're under the canopy of the rainforest, because the movement in the water translates to movement at the ground plane.
Yeah, it blurs the light even.
Just softens out all the reflections.
It's really great, particularly for a retail precinct, to be able to look up and see sky. And the experience of sky is even more interesting here because of the heliostat that's dappling that effect.
You're listening to Tilt, the podcast series that will challenge what you think you know about industrial design, exploring the fusion between industrial design, architecture, and construction. Hi, I'm Tim Phillips, and you're listening to Tilt. For our very first episode, we're going back to where it all began, the Heliostat at One Central Park. To help me, I'm joined by SJB's Studio Director, Emily Womwell, to explore the origin and design of this unique and exciting project. Emily is well known in Australian architecture for her thought leadership initiatives that aim to expand the focus of the design industry and provide a broader perspective on cross-disciplinary practice. With her team at SJB having conceptualised their own heliostat for a development in the west of Sydney, Emily is well qualified for talking us through the specifics of this exciting installation. Let's begin.
Today I'm delighted to be interviewing Tim Phillips, industrial designer and managing director of Tilt Industrial Design. an industrial design company that specialises in creating unique structures for the built environment. In 2009, Tim got a phone call that would change the direction of his professional career.
I remember the call I got from one of the principals of Atelier Jean Nouvel, Bertrand Bessel, and he was cold calling. He was looking for a firm that could help him develop a technology for One Central Park. It was really out of the blue. It was an exciting call to take from a Frenchman looking to an Australian company to help deliver this exciting concept for reflecting sunlight.
Bertrand Bessel was the design and project partner who relocated from Paris to Sydney to lead the One Central Park project for French architect studio Atelier Jean Nouvel. Led by their namesake Jean Nouvel, the studio is responsible for some of the most recognisable buildings around the world. London's Serpentine Gallery, the National Museum of Qatar in Doha, Torre Agba in Barcelona, and its pioneering project built in 1980, the Arab World Institute in Paris. Known for his boundary-pushing use of cantilevers, clever light manipulation, water, space and height, Jean Nouvel himself is one of the leading architectural figures of this century. So it's no surprise then that Frasers, the developers behind One Central Park, wanted to seek their expertise in creating a groundbreaking landmark for the former Carlton Brewery site. Here's Michael Goldrick, former Development Director of Frasers Property Australia and Development Director on the One Central Park project, to tell us how it all began.
Frasers wanted to make sure it was a sustainable precinct by having control of the whole of the site and to create the necessary critical mass to allow a lot of the sustainable features to be incorporated, and also using a collaborative of international architects. The intent was that OCP, as I said, was the tallest building, and it should be developed more as an iconic building for the precinct. The intent always of John's design had the cantilever, had the heliostats, and his sketch showed how the sunlight would be reflected by the heliostats down into the various parts of the building. The challenge then to find, I guess, how we were going to build it.
The plan was to put heliostats on the lower tower that would move throughout the day to reflect the sunlight onto the cantilevered structure above, subsequently reflecting sunlight into the park all day. The height, weight and functionality of the cantilever was without doubt the most challenging design and installation component of the project. So finding a company willing to take on the momentous task proved difficult.
I guess you go back to John's original sketch design and design intent, and he always had the cantilever. He always envisaged that there were heliostats and reflectors. He always envisaged that the park would be part of the building, and the building had terraces on the southern side going down into the park. So all of that was part of the original concept of Jean Nouvel. And, look, it had never been done before in Australia, vertical gardens and planters on a building that, normally 140 metres tall in Sydney was never considered or undertaken previously. And so the tasks were fairly daunting. When we were interviewing tenderers to be on the tender list, there are a number of contractors who openly said, you'll never build it, you'll never do this, you'll never do that. Their attitude was it was too hard to do. Well, fortunately, we were committed to Jean's design, and other tenderers embraced it, and they were happy to step up to the challenges that the design put forward. Tim and the team never wavered, I don't think, in what it was. They knew they could manage the design of the heliostats, and they were so excited, I think, about being involved in such a challenging project.
Providing outdoor space that can be used year-round was a major component in bringing the complex to life and fulfilling the site's public amenity objectives. Frasers and AGN needed to think outside the box to find a company who could deliver the component successfully.
The company I was working for at the time was called Kennovations, and we were conducting research and development for a solar thermal company in Western New South Wales to develop mirrors for them for tracking the sun for energy purposes. So we're really excited to get that opportunity to take the learnings that we had from that project and that industry and apply them to architecture.
So the Heliostat was a really early concept for Jean Nouvel. At what stage of the project had they reached out to you?
As far as I understood, the cantilever was the architectural expression or style of Jean Nouvel, and this cantilever in itself was something they were pursuing as an architectural feature, and then the integration of the Heliostat evolved from the site-specific geometry where the two buildings were in themselves creating a lot of shadow, and this technology represented the opportunity to offset the impact of the building but also create this dramatic intervention and supplementation of solar to the site. A large portion of the design was resolved, particularly with regards to the base building. They had in their architectural model representation of the form for this structure. They had done quite a lot of preliminary research with regards to ray tracing, which was the software they used to predict what they thought they could achieve with the mirrors and the available geometry on site. But again, there was an absence of detail in the design. So it was largely theoretical at that point, and they needed a consultant to help prove up the theory as a first step. But what they were really interested in was a company that could not just embrace the concept and prove feasibility, but deliver this on behalf of the development team, the architects, and the builders who were all involved.
So when you first started on this project, what stood out to you as the biggest challenge?
The location of the cantilever, which is 80 metres above the ground plane, represented probably the most intimidating component of the project. It was always seen as this great challenge to integrate our product into a location that's largely remote from the building. It's difficult to access, and we had to develop a robustness in this system that would mean it could last 20 or 25 years without any significant repairs. So the remote location of this system was particularly challenging, and access to these components, not just for installation, but maintenance as well.
Was the public art component already present at that stage?
The primary objective for the cantilever was always to provide solar supplementation, or always about the light, and the public art integration was a secondary opportunity, but one that dovetailed in really quickly. So the two were running in parallel throughout our design development phase at all times, with an equal level of importance. But I think the priority was always for us on the feasibility of this system, and the questions we were asked was, how much light can we get to the places that we want to target? So the initial studies we completed were about understanding the constraints of the site and the constraints of the technology, and then provide some tangible data around not just the amount of light, but the quality of light was also paramount for the architects to achieve this concept of naturally lighting the retail space, which was the priority, and this concept of delivering a very natural experience, because there was no benchmark for a project of this scale when we're talking about reflected light. So there was a lot of uncertainty around the concept of how to measure light or measure the success of this system. So how much light and what will reflected light look and feel like? So a lot of those questions we were trying to answer and manage the risk associated with.
So it's a light work, the public art. How did that affect the design of the cantilever and the Heliostat?
We received the public art brief from Jan Casali, who's the lighting artist, and essentially he provided video content and he provided the intent for what he wanted to deliver on the screen. So the cantilever system's about 30 metres by 30 metres, so that sets up a canvas for an LED screen. There's about 3,000 LEDs that are embedded into the surface of the mirrors. They're a bit difficult to see during the day, but obviously at night, and we have those 3,000 pixels light up, and we run video content across that surface. So the same process of assessing the intent, prototyping, testing different types of hardware, and then working out a way to embed that technology into the surface of the mirrors on the cantilever. That reflects that design development process we use for the mirrors themselves. So it's an exercise in mechanical design and structural engineering, as well as some classic industrial design. But essentially, we're trying to figure out a way to integrate those 3,000 lights into the surface of the mirrors and to support all of the hardware that comes with a substantial lighting installation like that.
So Tim, talk us through the process from design through to fabrication.
The first stage for us was to assess the feasibility of the concept, and that looked at identifying usable technologies to prove up that this could be achieved. Beyond the technology, we were looking at hardware. So we developed through computer modelling, prototyping, testing, and a set of documentations, essentially a design for each of the components. All of the mirrors on the cantilever are essentially one type of product, but there's 320 of them. And then the sun tracking mirrors, there's one product, but there's 40 of those in quantity. So we had designs for those elements. And essentially our role was to produce a set of tender documents that the builder could use to go to market to get a market response to design and construct this system. Ultimately, the company I was working for at the time, Kennovations, tendered for that contract and won it, and were engaged by the builder Wattpac to deliver this system under a design and construct contract. And a big part of our procurement strategy was to look globally for materials, technologies and components that would enable us to achieve this and provide a very robust system. So we had a global procurement strategy. We sourced our Heliostat, or our software technology, from a local company called Device Logic, who are working in the solar industry. We sourced components from China, from America, from Spain, from India, and we basically looked to the global marketplace and we brought all those components into Australia, and then we assembled the components here before installing them on site. And that opportunity to reach out to the global market meant that we could get the very best quality and the very best price and bring all of that together to help the developer achieve what they needed to achieve, not just from a price point, but from a longevity perspective as well.
Did any challenges arise with the geographic condition in terms of transporting materials and that kind of thing? Were there any issues that came up? One of the biggest challenges that we faced was maintaining quality control for a lot of the products that we did source out of China. That's again a common problem whether you're sourcing locally or overseas, but the provision of quality control in China was something that proved particularly challenging and rewarding at the same time as an exercise. That meant we were able to get the very best price, to maintain quality, and to bring in products that enabled this project to be a success. And if we'd looked to local supply for all of the components, we wouldn't have been able to achieve what we needed to do from a financial perspective. And then was there any assembly that then had to happen in Australia before then being moved to site? The beauty of a project at this scale is that you are offered the opportunity to prototype, and it's a really important part of the design process for an industrial designer and often in architecture. And every part of this project was prototyped. We're at a scale here where we've got mass production available to us, so we're talking about 40 very big mirrors and 320 smaller mirrors, but there's thousands and thousands of components in here, so the opportunity to prototype is something that we took advantage of. So we basically had a strategy of procuring the parts from that international marketplace that I spoke of, and all of the parts were brought to Sydney. We had a warehouse in Artarmon in North Sydney, and all of the parts were pre-assembled there, commissioned and tested prior to be delivering to site. Again, that's a really important part of the process for us to take control of, because we're making sure that the products that we deliver meet the quality objectives that we set out in our own design brief. We prototyped, as I say, almost every component, and that gave us opportunity to work with the architectural team, the structural engineers, and all the other stakeholders involved to get feedback which we could introduce back into the design cycle and improve the ultimate design. After a significant period of design, prototyping, testing and manufacturing, Tim and his team had fully developed both the Heliostat system and the 320 reflecting mirrors, which would interface with the 94-tonne cantilever structure. The plan was to fix the mirrors to the cantilever structure on the ground before crane lifting it 70 metres into the air and attaching it to a set of beams protruding out from the side of the eastern tower. But a week earlier, an almost disastrous crane fire at a building site across the road put tighter restrictions on their movements, and the plan was thrown out.
It was originally conceived that we would install all of those mirrors at the ground plane. So when that steel structure was assembled at the ground plane prior to it being lifted up by a crane, the intent was to install all of the mirrors at the ground plane and then lift the entire cantilever up as a single structure. During the time that we were getting ready for installation, there was a tower crane fire across the road, and subsequently a lot tighter restrictions on our own site around crane limits. So we sort of changed that process, and we decided that, or the builder decided that they'd lift the steelwork of the cantilever up, which is about 94 tonnes of steel, if I recall correctly, and pin that off to the structure. And then we subsequently used that access basket to go out and install all of the mirrors from the furthest row away from the building back. So it was just a really amazing experience of being suspended under the cantilever 80 metres up in the air. Some beautiful views out over Western Sydney, completely unobscured. And I spent a couple of weeks up there myself putting in the first couple of rows of mirrors, and that cantilever actually moves up and down quite considerably when there's high winds. And we installed about this time, I think it was August, September. So we're experiencing quite high winds up there, and it was a really unique experience. And from a view perspective, you know, it was really special to be up there in a place that no one else in Sydney had been before.
So you were an installer yourself on this project?
Yeah, absolutely. It's say everyone at Tilt goes through this process of design and supply and install, and you know, I worked hard in the design phase. I was a general manager of the company at the time and also a project manager, so my role was to not just develop the methodology for installation but also get out there and prove it could be done. So you know, we had a big team on this project. A lot of hands touched this product, but yeah, certainly enjoyed being out there during installation. I've certainly been out there many times for maintenance as well.
I want to ask a little bit more about the maintenance of the Heliostat and how that plays out.
There's two components in the system. On the roof of the Western Tower, there's the 40 large mirrors that actually track the sun and do all the mechanical work, and those mirrors are the key technology in this system, and that we access that from the rooftop space of the Western Tower. So that's very much a straightforward maintenance solution. Getting out to the 320 mirrors on the cantilever is a slightly different experience. There's quite a large, what we call a BMU, or a building maintenance unit, which is essentially a big steel basket that sits suspended under the cantilever, drops down on cables, and it traverses out to the end of that cantilever. So you can access the underside of all of those mirrors from this basket. So we utilise that basket not just for maintenance but also for installation.
So who pays for that ongoing maintenance?
The maintenance is funded by Strata. So early on in the design phase, we were providing the developer with insight into likely maintenance costs and life cycle costs as well. So we're looking at 10-year and 20-year life cycle management for these components. So really important again for the developer to have a look at the 25-year cost for a system for this. It's not just the initial install cost, but the cost of replacement and maintenance of parts each year and for many years. And that's a really important part when, you know, if we're looking for a residential project or a large commercial project, that the clients understand those life cycle costs before they commit to a manufacturing cost of a product.
So what was the biggest cost related to the Heliostat?
I think if you were to look at the cost of the process involved in design, in managing manufacturing and managing installation, the design fees would probably be much greater than the cost of the materials themselves. You know, inherently this is a relatively high value object, but the amount of time and the resources that go into managing the risk in the process, I'd suggest that the consultancy fees are probably higher than the cost of the materials themselves. And in fact, we were given a very strict budgetary guideline at the start of this project to focus on. So our design process actually was targeted towards an agreed budget, one that the developer had decided was an appropriate investment for this feature. So the design process itself was very much focused on controlling cost, understanding the investment in materials and processes, then being able to put that package price together for the developer and have them agree that that's a good investment and a reasonable investment. That means that in the tender process, they're not necessarily looking for the cheapest solution because they know the cost of it. They're looking for a team that can deliver the quality that they've set out to achieve.
So what do you think the smallest cost was? The mirrors?
Oh, there's 30,000 rivets up there. They're probably one of the cheapest things that went into it. As I say, the cost of materials is relatively low. We are using aluminium and we're using steel to achieve some really exciting designs, but it's just in a non-traditional way. So the individual components are not particularly expensive, but for instance, the installation process where we've got half a dozen installers out in that cantilevered area for weeks at a time installing can be very time consuming. So it's the people and the process which cost time to achieve. And I think I've even got some team out there this morning doing maintenance on the heliostats, and it's a really special experience for our staff and most staff who have joined the company since we completed the project several years ago now to go and service this and experience the product and go out into that vantage point, which is one that provides beautiful views and a really unique experience.
What's a true commitment to the product?
It's part of the promise that we make when we pursue these really challenging and unique concepts is that someone has to look after them into perpetuity, and we have to make sure that the client feels confident that after we finish our initial contractual obligation to install it, that it's going to work for years. So, we have to continue to provide software updates, and we have to go out and make sure the lights are still working. So that after sales service is a really important part of what we offer as a business.
So on large-scale projects like this, there's obviously a huge number of people involved, and this component alone probably engaged a lot of people. Do you have any idea of how many people do you think it took to get this thing delivered?
These types of projects are very much multidisciplinary. So outside of the team from Jean Nouvel's, we also had the local architects, PTW. We're working with Robert Bird as the structural engineers. Within our own team, we had mechanical engineers, electrical engineers. We were working with lighting experts from Arup. So hundreds and hundreds of people have touched this project at different points in time, and that's not uncommon for any architectural pursuit. But we certainly tapped into the resources of a lot of specialists to make this work.
Overall, what was the most difficult part of this project and the process?
I think the challenge in most of the projects that we set out to achieve is making sure that all of the stakeholders are excited by the outcome and no one's suffering significant compromise by what we put forward. So we have at the front of mind all the time the architectural intent. And then we're trying to manipulate all of the other stakeholders around, like structural engineers and manufacturers, to make sure that we can deliver what that intent is. So for us, the many stakeholders to please is the challenge. And to get to the end of the project and be in a position where we can see the architects talk with such satisfaction or excitement, and the developers talk about the success of the site, and the engineers, designers all be proud of what we've achieved. That's the hardest thing to do on every project, but I do think we achieved that for this.
When you look at the Heliostat now, what gives you the most joy or satisfaction?
My experience in this project was one of bringing industrial design to architecture and seeing the opportunities for what I do as a career and what I see as an exciting discipline to really add excitement to architecture. And that's where Tilt was born. I was working in engineering consultancy. I saw what we were able to do for architecture and within the built environment on this project. And then to me, that's what sparked this opportunity to go and start Tilt. And in fact, it was about buying that company and converting it to be Tilt and taking all of that excitement of industrial design, building something amazing in architecture.
As an architect myself, I know that at earlier stages of design, you're kind of focusing on the solution yourself and not necessarily thinking of reaching out to an industrial designer. So just wondering, at what stage do architects generally get in touch with you?
I don't think many architects think of industrial designers at all. That's part of why I've brought the business to life. It's a realisation that we are not a discipline that architects traditionally see as a way to achieve building outcomes. And that's just the truth. And I still think 99% of architects across the world would think that way. And probably 95% in Australia. Hopefully we're educating a few about these opportunities. But look, it's just not traditional procurement. So we need to educate architects on this opportunity. That's a big part of what I do, is about helping them understand how working with an industrial designer can lead to these types of outcomes and exciting outcomes of all different types of scale. So I think my role is to use projects like One Central Park as a benchmark for what can be achieved when an architect looks outside of that traditional procurement process, where they might go to a structural engineer or try and call a fabricator and run into all these barriers that prevent them from pursuing what is achievable and what ultimately gives them the best architectural outcome. But these traditional paths of architect to builder and builder to trade prevent concepts like this from being achieved. So unless we can, I don't like to use the word disrupt, but we're kind of trying to interrupt that process and say, guys, there's another way to do this. And the earlier in that process, the better, because we have to focus on all of the things that an architect knows are important, not just the functionality, but the cost and the process for delivering this. We like to see sketches. That's the best time, when I get a sketch come across the desk, something loose and conceptual, because that's when we can have the most impact.
Yeah, I think that's a comment you've made to me before about how you can look to other industries that are using these different technologies on the daily and on huge scales, and actually that experience can take the risk away from using it in architecture. It's just that it's not transferred to that industry very often. So that's the difference. But there are ways to give your clients the confidence they need, because it is done so vastly in other industries that we're not aware of.
Yeah, One Central Park's an excellent example of an existing technology translated into the built environment, and that's very much the premise for how we achieve our design outcomes. We're not trying to invent, and we're not trying to pursue projects that have a high level of risk. We're trying to manage that risk. And by bringing in these existing industrial technologies or existing software systems, whatever it might be, we're able to achieve things. So it really is about finding appropriate technologies from another place and just massaging them to suit architecture. And by doing that, it makes people feel like this is very much achievable.
So looking at the end result, were there any compromises made from the original design?
I think the final design is very much aligned with what we saw Jean Nouvel's team put on the table. It was optimise in order to not just control cost, but to respond to the limits of the site. For instance, the size of that cantilever, how much it can respond dynamically to wind loads was very much a limiting factor. So it's not the cost of the components there. It's factors like wind loading that have a bigger impact on how many mirrors you can put out there and what size they can be. But Jean Nouvel and the PTW team had put in an enormous amount of research and developing into the concept, and our job was to stay as close to that concept as we could, and I think we've achieved it.
Obviously it was an important project for the beginnings of Tilt, but aside from that, what was your favourite part of the process?
I think the fact that people don't really understand what the Heliostat does or how it works is one of the most satisfying things. It tells me that we've achieved something that's intriguing and exciting, and that's what I love to do for architects. It's about understanding that they have this vision, or they have this capability of developing a vision, but they just need support to achieve it. And it is a remarkable achievement from a multidisciplinary perspective, and that's very exciting to me.
It's certainly iconic. A lot of the public recognise it and know of the project, but as you say, don't necessarily know the full functionality of that element. which is interesting.
And I don't think many people understand when they are enjoying the benefits of it either. It's a very passive system, such that you can walk through the park and be in a reflected patch of light, but not wonder where it came from. And you can wander through the shopping centre and be drenched in natural sunlight, but not wonder, how is this happening? So it's a really interesting natural experience from a man-made intervention. And that's, I think, a really good indicator of its success.
The scale of work involved with this project was immense. Bringing the vision to life required significant collaboration, planning, and design expertise across a range of industries: engineering, biomechanics, botany, construction, architecture, and industrial design. Successfully delivering an exceptional barrier-breaking landmark in the Sydney skyline, and a monumental symbol of a new way of designing and future-proofing cities and public spaces. For Tim, this project is even more monumental as it opened his mind to the potential for industrial design in architecture, marking the beginnings of Tilt and a passionate drive to bring industrial design into the built environment. I'm Emily Wanwell, and you've been listening to Tilt, exploring industrial design and architecture.
That was Emily Wanwell, Studio Director at SJB, and I'm Tim Phillips from Tilt Industrial Design. See you next time, and thanks for listening.